All right, good morning, guys. So today we will finally start to talk about solving equations. All right, so solving equations or equations in general, I'd say probably about half the course, right? Not necessarily just solving equations, but using linear equations, different formulas that involve equations. So we're going to kind of start from the beginning with one-step equations. These should definitely be things that you guys have covered last year. You should have done two-step, you should have even done multi-step, but we're going to review it all starting from the beginning. So we're going to first take a look at our do now, just to wrap up the last lesson about distributive property, and then we'll start to talk about equations. So for number one, I'm going to distribute the negative 5. So negative 5 times 3a is negative 15a. Negative 5 times negative 2b is positive 10b. Negative 5 times negative 6 is positive 30. For the second one, I'm going to distribute the 3. And I'm also going to distribute the negative 5. We want to remember that. So that becomes negative 10a, and then negative 5 times negative 11 is positive 55. I'm going to box my variable terms. So 3a and negative 10a gives me negative 7a. And I'm going to circle my constants. 24 plus 55 should give us 79. So negative 7a plus 79. And at the bottom here, we're going to distribute the 4 to give us 4x minus 36. I'm going to distribute the negative. Again, we can call it negative 1. We can call it the opposite. If you need to write in the negative 1, you can do that. So that gives me negative 4x. And then negative 1 times negative 5 is positive 5. I'll be consistent and I'll box my variable terms. 4x plus negative 4x gives us 0. And negative 36 plus 5 should give us a final answer of negative 31. All right, so let's talk about what an equation is, right? So this is the time if we were in class, we'd have the discussion about an equation versus an expression. So an expression is a combination of variables, numbers, or both, right? So this is an expression. This is an expression, this 5 is an expression, and 2x plus 5 is an expression, okay? We put an equal sign and then we put a quantity, whether it's a numerical quantity or a variable quantity. And now we have an equation, okay? An equation is two equivalent expressions separated by an equal sign. So how do we solve equations? Well, we know that an equation is like a balance, and I'm kind of doing the thing with my hands I would be doing in class, where I hold my hands out kind of flat like a triple beam balance, but that's what an equation is, right? We think about it like a triple beam balance, sort of, right? So if I've got some stuff on one side and some stuff on the other side, they're going to balance. If I add 5 units to one side, it's not going to be balanced unless I add 5 units to the other side. If I want to take away 20 units over here, I can do that as long as I take away 20 units on the other side. If I want to double one side, I can do that, but I better double the other side as well. So that's how we maintain equality. If we just do something on one side, it's not an equation anymore. It's not balanced. So let's take a look at what we're going to do, right? So in the younger grades, sometimes we are mistakenly taught to do the opposite operation. Now that will work a lot of the time, but it's not going to work all the time when we start to get into real algebra, which is what we're doing. What we actually do is we isolate our variable, and we do that by eliminating anything on its side. And the way we do that is we add its opposite. So the first one here, x minus 12 is equal to 42, I see the x on the left side. I want to eliminate the negative 12. The way I'm going to eliminate the negative 12 is by adding its opposite, because I know the sum of any expression and its opposite is 0. But I can't just add 12 on the left side, I have to add it on the right side as well. So here's what's going to happen when I do that addition. Negative 12 plus positive 12 is 0, right? So in math, so you're going to see me do things like this, right, where I cross something out, right? So a lot of the time we'll use language like, I canceled it. And if we were in class, I would say, well, what does that mean that you canceled it? Cancel is not a math word, okay? I'm using, in blue, I crossed that out to represent the fact that the sum of negative 12 and positive 12 is 0, and those terms are then eliminated. So I bring down x. I don't need to put plus 0, but now I'm going to add 42 and 12, and I'm going to end up with x is equal to 54. All right, so that's my solution for this first equation. Now, I'm not going to check every equation because this lesson would be 3 times this long and it's already going to be pretty lengthy. But I will check the first one and maybe I'll check 1 or 2 more. Okay, x minus 12 equals 42. So there's 3 steps to check an equation. Step 1, rewrite the original equation. Step 2, substitute the value that you get for your variable. And step 3, evaluate using the order of operations. So I think x is 54, so I rewrote my original. I'm going to replace x with 54. And now order of operations tells me, well, I've only got one operation, and that's my subtraction operation. And I've got 42 is equal to 42, okay? So that's how you would solve and check a very basic one-step equation. Let's go down to the second one, x plus 11 is equal to 3. Well, that's going to be no different, really, than the first one. I see that x is on the left side. I want to isolate it. So I want to get rid of that 11, so I'm going to add its opposite on both sides. So positive 11 plus negative 11 is 0. And again, I'm not canceling anything out, but I don't have to write 0 or plus 0. And 3 plus negative 11 is negative 8. So that was nice and easy. And if I check it, negative 8 plus 11 is 3. That should be a nice, easy one. All right, so let's move over here. Give myself a little extra space. So this is when we want to kind of unlearn some of the things we may have learned in the younger grades when we talk about doing inverse operations. All right, the operation is negative 8 plus x, which would imply some sort of subtraction as the inverse, but that's actually not correct. I want to get my x, which in this case is positive x, isolated. What do I need to do? I need to eliminate that negative 8. How will I eliminate that negative 8? By adding positive 8 on both sides. So I'm going to add positive 8 on both sides. So on my left side, negative 8 plus positive 8 is 0. X comes down. Negative 25 plus positive 8 is negative 17. And if we check it, negative 8 plus negative 17 is in fact negative 25. All right, so these are going to be a little bit trickier. So let's look at the first one. It says 15 minus x equals 23. Okay, well, now my x is negative, which is actually going to make this technically a two-step problem, which we will do again when we encounter two-step equations pretty soon. So my question is, and again, this is another one that's a little deceptive because we see the subtraction, but we're actually not going to do the opposite of that. What do I want to eliminate? I want to make this 15 disappear. I want to just leave my negative x on its own. How am I going to make that positive 15 disappear? By adding negative 15 on both sides. All right. Now, a lot of teachers will say, what's the next step? Subtract 15. I do that a little bit differently. I'm never going to say subtract. I'm always going to say add the opposite. So either I'm adding a positive number on both sides or I'm adding a negative number. I am never using subtraction because subtraction of integers is going to be more difficult than adding a positive or adding a negative, just to be clear. So what happens on the left side? Well, 15 plus negative 15 is 0. What happens on the right side? 23 plus negative 15 is 8. Now, what comes down? This is really important. That negative doesn't just disappear. It doesn't just blow away in the wind, right? That negative x has to come down. Now, we need to think about what negative x means. So we can do this in a few different ways. This says the opposite of x is equal to 8. Well, if the opposite of x is equal to 8, then x has to be equal to the opposite of 8. So I'm okay with you doing that, with you switching the signs. It's not the most mathematical way, and we're going to talk about what the real mathematical way is, but it's okay. You can do it. Now, what do we really want to do? Well, we really want to say that that negative x is really negative 1x, and we talked about this with the distributive property earlier. And what am I going to do now on both sides? Well, we're going to get to that a little bit later. You're going to divide both sides by the coefficient, which is negative 1. So negative 1x divided by negative 1 is just x, and 8 divided by negative 1 is negative 8. So what do we end up with? We get the same answer as if we did that sort of switching the sign strategy. So I don't like to teach, tricks and shortcuts and things like that, but if you understand what we're doing, right, you can do that. What am I doing? Well, if the opposite of x is 8, then x is the opposite of 8. That's just logical. Mathematically, what are we doing? We're dividing both sides by negative 1. All right, let's look at this next one. We have negative 20 plus x is equal to negative 20. So now, again, I'm going to try to think logically, and I'm going to say, if something plus x is equal to that something probably has to be 0. Now, how can we prove that? Well, I want to eliminate negative 20. So I eliminate negative 20 by adding its opposite on both sides. So let's see what happens. Negative 20 plus 20 is 0. Negative 20 plus 20 is 0. So x equals, well, I can't just leave it blank. So in this case, I actually have to write 0. Right over here, let's just to get back to over here, I didn't put 0 minus x, right? I didn't do that with the last slides either because it was unnecessary. Here it is necessary. I can't just leave a side of an equation blank. Side of an equation blank generally means 0. So let's think about the check. Negative 20 plus 0 is negative 20. Well, that makes perfect sense. Okay, so now let's do some that involves some division. So 3a means 3 times a. So we're trying to figure out 3 times what number will give us 21. And again, logically, we can probably figure out that that number should be 7. And the way we prove it is we divide both sides by the coefficient, which is 3. So 3a divided by 3 is just a. And again, sometimes we do this. We cross it out, right? And if I say, what did we do? Everyone's going to say, we canceled it. And I'm going to say, what does that mean that we canceled it? The answer is, if you multiply and divide by the same quantity, it's like multiplying by 1. Right? If I take something and I multiply it by 10, but then I divide it by 10, it's like I didn't do anything. It's like, so technically I multiplied by 1. So that's what's happening. I'm dividing 3 by 3, which is giving me 1a. So let's try to get, and it's hard without verbal feedback and stuff like that, but I'm going to do my best and try to point out all those little things, those little problems that I see us make, especially with the language. We're not going to say things like cancel. We're going to say we divided it out a common factor, things like that. All right, let's look at the second one, same thing. Negative 10 times what is equal to negative 70? I'll divide both sides by the coefficient, which is negative 10. Negative 10 divided by negative 10 is just equal to 1, which is what we're showing there, right? Negative 70 divided by negative 10, since the signs are the same, is going to be positive 7. Now, just to do a check, maybe I'll do the check on the first one, just so you see it here. We said the steps were that you rewrite the original. You substitute the value for the variable in parentheses, and then we evaluate using order of operations. All right, so that's what your check should look like. And again, this is something you definitely should have done last year quite a bit. Let's take a look at some division equations. So some larger number divided by 9 will give us a quotient of 11, right? A quotient is the result from division, which we talked about with order of operations a little bit, or with the verbal phrases. So what am I going to do? I'm going to multiply both sides by 9. What did I just do there? And of course, someone will say, you canceled it out. And I'm going to say, what does that mean I canceled it out? Well, let's talk quickly about what I did. I multiplied 9, which has a denominator of 1, by x, which has a denominator of 9. Now, what would that give me? It would give me 9x divide 9. Now, what do I notice here? I can divide the numerator and denominator by 9, and it just gives me x. Am I going to show that work every time? No, I'm not. I'm going to show this. I'm going to show the slash. But I want you guys to understand, anytime I do something with a symbol, and if there's something that I do that you don't understand, you need to let me know in the comments so that we can talk about it in the next lesson, or I can talk about it with you. But we don't just throw these little slashes around and talk about canceling things. All right, so back to the problem. So we were just left with x over here is equal to 11 times 9, which is 99. And if we want to do a quick check of that, we rewrite the original, we substitute, and we do our division. And there's your check. All right, now let's get back to this second one here. This one's going to be a little trickier, right? So we're going to multiply by 7. And that's going to give me negative x equals 21. Now let's get back to what we talked about before. If the opposite of x is 21, then x is equal to negative 21, right? What did we do? I'm going to just go back to it because this is taking a little bit longer here. I divided both sides. Sorry, I got to go back a little further. I divided both sides by negative 1. Okay, and that's the exact same thing that we're going to do here. Okay, and we get negative 21. And if we check it, negative 21, of course, becomes positive 21. Divided by 7 will give us 3. All right, so let's take a look at these fraction equations. So I've got 1/4 x is equal to negative 7. What do we do if we've got a fractional coefficient? We're actually going to spend 2, maybe 3 days on equations with fractions, because I know that's always a trouble spot for a lot of us. But for today, what we need to know is you're going to multiply both sides by the reciprocal of the coefficient. So let's talk about that word, which we've talked about a little bit before. Coefficient. So the coefficient is the number that the variable is being multiplied by. Why do we multiply by a reciprocal? Well, we should know that multiplying any expression by its reciprocal gives us 1, right? So 7 times its reciprocal, which is 1/7. And again, the reciprocal is when you switch the numerator and denominator of a fraction, is always going to give us 1, and that's what we want, right? We're not solving for 1/4 x, we're not solving for 3x, we're solving for 1x. So let's see what happens here if we multiply both sides by 4. 4 times 1/4 x is just x, right? Or technically, it's 1x. And then negative 7 times 4 is negative 28. This one's going to get a little tricky, right? 3/5 x. So what could I do? Well, I could multiply by 5, right? And that would give me 3x. And divide by 3, that's a little bit inefficient, though. We said before, you can multiply both sides by the reciprocal. So you're going to have to multiply both sides by 5/3. Now, what's 3/5 by 5/3? Well, if our rule is correct, multiplying any fraction by its reciprocal should give us 1. So 15/15 is in fact 1, so we've got 1x. And 5/3 of 12 we can do in a few different ways. You can use your calculator, but really I know 1/3 of 12 is 4, so 5/3 of 12 is 5 groups of 4, which is 20. And if we check it, 3/5 of 20 is in fact 12. All right, guys, so here's your now try. All right, so I want you to try these, okay? And you can pause it to try them, and then I'm going to go over it. So for the first one, I get x minus 17 equals negative 3. I'm going to add 17 on both sides. Negative 17 plus 17 is 0. Negative 3 plus 17 is 14. And if we check it, 14 minus 17 is negative 3. Let's write out the second one. Negative 14 plus x equals negative 10. Now this is another tricky one, right? All I care about is the sign of that 14. And since the sign of that 14 is negative, I'm going to add its opposite on both sides. And I should have put an addition sign up there. I need to eliminate it. So negative 14 plus 14 is 0. The x comes down. Negative 10 plus 14 is 4. If I go back and check it, negative 14 plus 4 is negative 10. For the next one, I've got negative 5x equals 45. That's a nice, easy one-step equation. I'm going to divide both sides by the coefficient, which is negative 5. That's going to give me x equals negative 9. And for the last one, I get negative x divided by 3 is equal to 8. I'm going to multiply both sides by 3. That's going to give me negative x is equal to 24, which means I can divide by negative 1, and it gives me x is negative 24. And again, when I check it, I substitute negative 24, which is positive 24, and that divided by 3 is going to give us positive 8. Now, a couple other things I want to do very quickly, just try to expose you to different things kind of in advance, right? I try to, when possible, kind of look ahead a little bit, so when we see things like this, we're not seeing them for the first time. 3a is equal to 7. Well, I know that's a problem because 7 is not it's not a problem, but I'm not going to get an integer, right? So I'd say, all right, guys, what do we notice about this? And someone would say, well, 3 doesn't go into 7, or 7 is not a multiple of 3. 3 is not a factor of 7. I'd say that's correct. And I'd say, does that mean we can't solve it? And someone's going to say, no, it just makes it a fraction or a decimal. Now, when in doubt, we would much prefer fractions over decimals, okay? If it is a terminating decimal, like 5/10, right? If your answer is half, you can leave it as half, like 0.5, 5/10. But I would much prefer, in general, you use fractions, and I will show you why. So I divide both sides by 3. Look how easy that was. I don't need a calculator. I don't need to do anything. A is equal to 7/3. If you try putting this in your calculator, you're going to get 2.33333, and most calculators will add a 4 at the end, and you're going to be very confused by that. Or no, I'm sorry, they're not going to add the 4. If it was 8/3, they're going to add the 7. But calculators do kind of strange things sometimes with the repeating decimals. Point being, we would much prefer a fraction because you're not going to want to check an equation and put in 2.33333. That's going to get a little tedious, and it's also not going to work when you go to check it. All right, for the next one, same thing. We're going to divide by 20, and this is nice and simple. X is equal to 12/20. So you can see how it's going to be, one, easier for us to solve an equation that's the answer is not integral, meaning an integer, and leave it as a fraction. And we will simplify this fraction by dividing the numerator and denominator by 4. Right, that'll give us 3/5. And if you love decimals, you can say 6/10, right? 0.6 as in 6/10. But it's certainly going to be easier for us, even using a calculator, to just leave the answers as fractions. All right, guys, so there is your homework. As you can see, in case I did not make it clear enough, you're going to solve and check. You're going to show all these steps. So as a guideline, right, you're going to go back and you're going to look and say, how did Mr. Capasso solve these equations? That's the work that I want to see, okay? I do not want you to say x equals 12, x equals 4. You will receive no credit for that, okay? There's, we talked about photomath. There's a million ways that you can kind of get around it. I want to see your work, okay? You're not going to copy this from someone else. I want to see you write it out. If you struggle, I want to see you struggle, and I want to see what you did. That will allow me to help you. If you struggle and you get the answers and the work from someone, that is not going to allow me to help you, and that's not going to let me know what you're having trouble with. So I need you to do your best. For each of these, you're going to write it out. You're going to show the one step. They are one-step equations. Number 4 and 6 may take you 2 steps. Okay? The rest of them are one-step equations. I want you to do your best, even if you struggle. And again, show all the work and make sure you check. If you don't check, I can only give you half credit. So make sure you check for every one of these equations and let me know if you guys need some help.